The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, an award-winning podcast where we reach into the core of the .NET technology stack and, with the help of the .NET community, present you with the information that you need in order to grok the many moving parts of one of the biggest cross-platform, multi-application frameworks on the planet. I am your host, Jamie GaProgMan Taylor. In this episode, I talked with Felienne Hermans about her book, The Programmer's Brain. This is a slight departure from the normal content of the show, as I feel that the knowledge found in Felinne's book is rather important to all developers who want to learn new things, which, let's face it, is what we do on a daily basis. Along the way, we talked about how learning works, how our brains work with prior knowledge and context to solve new problems, and how IDEs should really allow us developers to make annotations without affecting the codebase itself. We also discussed Heady, a programming language for students in the 11 to 16-year-old range, and Felinne's code reading club. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So the first thing I'd like to say, Felienne, is thank you ever so much for agreeing to be on the show. I know that we're not really going to talk about .NET and C# today, but I figured that it's a skill that I think all developers should have. We should all know a little bit about how our brains work and how we learn stuff, even if we each have slightly different ways of learning. It's important to know the fundamentals, as this will help to boost your learning and help you to write code for other developers. And I often say that as soon as you hit save, you are a different developer. You might not be able to remember or understand the problem from a few minutes ago as soon as you hit that save button. So I'd like to say thank you so much for being on the show, and welcome to the show, by the way. Would you mind giving us a bit of an introduction to yourself for some of the work that you do?
Yeah, of course. Thanks for having me on the show. My name is Felienne Hermans, and my main job is that I'm an associate professor at Leiden University in the Netherlands, where I research how people learn programming. And in addition to that, I also teach in a high school myself and in a teacher's college. So I also help prospective teachers to become computer science teachers in high school in the future.
That's a lot. I mean, I just write business line applications that feed something into a database, get something out of a database, and then put it back in. Right? That's all I do. You're doing loads of stuff.
Yeah, I guess it's true.
Oh my goodness. Okay. So one of the things that we're going to talk about is a book that you released. I believe it was 2021 that it came out.
Yes.
I heard about it in 2021. Oh, it was. Okay, excellent. And it's called The Programmer's Brain. And it's all about how your brain works, right? And I feel like it's not necessarily that us programmers, our brains work differently to everyone else. We have a certain flavor that makes things maybe a little bit more logical, but everyone's brain on a fundamental level works the same way, right?
Yeah, true.
When it comes to learning, right? We all take information in, we store it somehow, and then when we need it, we pull it back from long-term memory, right? That's what I knew going into the book.
Yes, that's kind of correct. Yeah.
Okay, excellent. I mean, is that the way that it works, or is there how does the information jump off of the screen into? Well, now I'm assuming that I'm talking about a person who can see, right? How does information, when I look at a screen, it jumps off the screen into my eyes, some magic happens, and then I remember it 2 weeks later? What's that all about?
Yeah, so there's some basic building blocks in between. Firstly, information is stored. Well, firstly, it's in your sensory memory. So this can be through your eyes or through your ears. Some people also listen to code if they don't have a vision well enough to read code with their eyes. And then this is a little bit like an I/O buffer. So very briefly, your senses store information, and already there some information is lost. So not even all information that you see and hear goes into your brain, because otherwise it would be very overwhelming with all the sounds and colors around you. Then the first thing happens is the information then from the sensory memory goes to the short-term memory. And this is also a bit like a buffer, also a very short buffer. So the information can live there for a few seconds and only very limited pieces of information can be stored in your short-term memory. Some of that information might then travel on to your long-term memory. So some of the things that you might look at, you might remember. Like I might remember your name or the fact that I was on a podcast this morning. Some information is stored to me, but maybe I get 100 emails. And, some of them I might forget about. They do not go into my long-term memory. And there are many things that influence what goes into your long-term memory. If something is very special, very important to you. If you have if you get a really angry email, more likely that it will be remembered because there's emotions associated with it. So one thing that is important to remember is that, which we sometimes forget, I think, as programmers, is that it is not enough to see something once, then it isn't necessarily always stored in your long-term memory. And I do struggle with that myself still in teaching students, right? It's like, teacher, how does a while loop work? I'm like, well, I explained this to you once, 2 weeks ago. How do you not remember this? Well, yeah, sometimes it takes a bit of time.
So what I'm getting, this is a jokey aside, but what I'm getting from that is the angrier I am when I'm reading code, the more chance it's got of going in because there's an emotion involved.
Yes, but it could also be another emotion. It could also be like happiness or like trust or something that you enjoy a bit more. But it is true. If there's code that you really struggle with to understand and it takes you a long time, you're like, oh, this was really hard. Then there is maybe a bigger likelihood that you will remember. Although it might also be the case that you remember the emotion, but not the things you learned.
Sure. I can attest to that as an allegorical story. There have been plenty of times when I've been looking at some code that's maybe intentionally obfuscated. Maybe the original author is trying to be really clever and said, hey, I can do this in one line, and it's actually across 15 lines in the IDE. It's a single statement, but it's 15 lines long. And, that I then get angry and I can't understand what's going on. So I can attest to that because all you're going to remember is the emotion, right? You're going to see the piece of code and you're going to be like, this is the piece of code that made me angry last time. You're not going to remember this is the piece of code that does that really clever thing, but in a really horrible way.
Yeah, and actually, if code is very difficult, so there's also a part of the brain that we didn't talk about yet, which is the working memory. So your working memory is a bit like the processor in your brain that really processes information. So the busier your working memory is with something, the harder it can be to remember something. So if you are really struggling with code and your brain is very much focused on what is going on here, then your working memory is so full, so overloaded that it doesn't have enough space left, so to say, to actually store something to your long-term memory. So sometimes it can also be that code that you really struggle with a lot, independent of whether or not it makes you angry or happy, code that is really difficult to understand will then also be difficult to remember because your brain was very much focused on what is going on and did not have enough room left to actually remember something. So sometimes you have this code where like, oh, I remember this was really hard. I remember struggling with this in the past, but I don't remember what the outcome was. And this is because your working memory was working too hard and it didn't give you space to save.
Okay, excellent. So what you're saying is I shouldn't work too hard. That's what I'm saying. That's what you're saying, right? Don't work too hard, Jenny.
Definitely, yes. So if you feel that something is really hard and you also want to remember, sometimes you do something as a one-off, right? This is one time you dive into a library and you figure out how to do it, you do it, and then you're done. But if you realize that this is something that you want to do more often, code that you will interact with more often, it is a good idea to, not necessarily work hard, because remembering things is also hard work, but to slow down and to try to deliberately write down the things you found, even though in the moment you might think, oh, I have no time for this. No, I want to understand. So do try to take a bit of room, a bit of a breather, and like, okay, so what is it I've done so far? Let me write this down. Then you can also commit this to the documentation, but also just the act of stopping and giving your working memory a little bit of time to catch up, that will help in remembering.
You see, that's really interesting to me because some of the junior developers that I've worked with, and I fell into this trap when I was a lot younger myself, would be I have the computer, I have the keyboard, I have the mouse, that's all I need. and I will just type, and eventually the program will work. Whereas what I have found myself doing these days, and I think it's very different to something that you mentioned in the book that I'd like to talk about in a minute, is I'll have a piece of paper, or if I'm a little bit more worried about the environment, I have a tablet that I can write on, and I just write down things like, what do I need to do? What can I see right now? What is it that I think the code does, right? And then I start to answer those questions as I'm looking through the code. Rather than trying to do it all at once in my head, I actually think, what is the code doing? What do I need it to do? What do I have? And what do I like? What is the input into this system, this method, this function? And what is the expected output? And how do I get from A to B? Rather than just sitting there going, right, okay, type, and then hopefully it works.
Yeah, and I think this is your first sort of intuition, or the intuition of young developers, to just type a lot. I think this is not something that magically happens. This is partly also due to the way we teach in university, right? Because what do you do in university? You get a prompt like, oh, you have to write a code that, I don't know, prints all prime numbers up to a certain threshold, or calculates the square area or something. So it's always very focused on writing code. There's not really a course in university that is reading code or debugging, or here's a library someone wrote 20 years ago, figure out what's there, or decide if this is a library you want to use. These are not really skills that we practice. So it's reasonable if in an undergrad program, or 3 or 4 or 5 years, students are writing code all the time, then they think, okay, this is a job, because sort of tell them, literally, this is the job.
Absolutely, and I wonder if that's. I think we've kind of discussed this on a. Well, I say we, right? My co-hosts and I have discussed this on a different show before, about the differences between academic study of programming and the real world, right? And there is a difference, and I think perhaps because in academia you have a semester, which is 12 weeks, 13 weeks, maybe 2 semesters
like
to teach someone enough of something so that they can go out into the real world and do it. And, as much as programming is, the act of programming is different to the act of building an application or something like that, right? Because programming, you sit down and you turn this is my understanding, right? This may not be everyone's understanding. It may not be the academic understanding. It may not even be your understanding or anyone else's. My understanding of programming is turning a set of rules into some syntax for a computer to run through. The act of building an application is partially programming, mostly debugging, and mostly reading other people's code and gluing bits together, right?
Yes, and also, of course, in university, we don't emphasize teamwork that much. So there might be a lot of programming courses in which we ask students to do individual work. And then maybe here and there's something like software engineering course in which you work as a team. But programming as a team, so programming is also different than developing software together with different people, which almost everyone works with other people in open source or in companies. But that's also not really a skill that we practice, how to write something so that you can reasonably expect other people to read it. What types of other people's might my code base attract? What type of juniors are we hiring? Did they learn Pascal, or did they learn JavaScript, or did they learn Java or C? What is the prior knowledge that we should expect from people that join? Yeah, that's another thing we talk about.
Mm-hmm. And I think that again. I think it's required because in a university setting, in a schooling setting, in a code camp setting, wherever you're learning, you only have a certain amount of time to teach as much as possible, right?
Yeah.
And I remember when I was at university, one of my lecturers was teaching us C#, but was using the command line and Notepad. And so every lecture was kind of like watching, like these days, it would be Twitch, right? What he was doing, he was doing live streaming, but he wasn't doing it. He was doing it inside of a lecture theatre. And what he'd do is he'd plug his laptop in, bring it up on the screen, go into the command line, do Notepad, and then some file.cs, type his code out with the font set to 1,000,000 or whatever, and then do CSC, which is the C# compiler at the command line, pass in the name of the source file, and it would build. And he would say to us, I'm not going to teach you Visual Studio because you're not learning Visual Studio, you're learning programming. And I think that was a key difference for me. That was a big differentiator. He didn't spend time showing us how to use Visual Studio or how to use any of the tools that were available that were visual, that were the full IDE toolset, because he was teaching us how to bubble sort, teaching us how to insert sort, teaching us how to write to the screen. None of that has a requirement on these tools, but they're nice to haves, right? But he was focusing all of his time and attention on Notepad works, the compiler works, I'm just going to do those two. Because obviously there's updates for things all the time, right? And he could walk into a lecture and everything's broken.
Yeah. And this is actually a really nice teaching strategy. So I'm not sure I agree with notepads and not using tools. I think I don't agree there. But I do agree with showing the act of programming as a teacher, rather than just having slides with code, because unavoidable, probably your professor also made typos, right? This happened, or he mixed up 2 or 3 variable names. This is just a thing that happens. Like, oh no, I meant the other variable, especially with Notepad without autocomplete. But this is very valuable, actually. So students see, this is what an error message looks like. This is what might be the root cause if I see this error message. Experienced programmers, they still forget semicolons. So that act of, what we now sometimes see on Twitch, that like live programming as a sort of almost an act of a performance, that is a very valuable way of teaching.
Absolutely. And I think, like you say, it was a lot. So there were other lecturers who would bring in slides of code samples, and it would be, so here is the code sample for opening a socket and sending, right? And at that point, I don't wish to be offensive to that lecturer. Nobody's paying attention, right? Yeah. If you're forcing everyone in the lecture theatre to read something that is 75 lines long on a single slide, or split across 2 slides, no one's paying attention, because different people read at different speeds. As you were saying, people have working memory that works at different speeds. And so if I'm struggling to follow along and then the slide switches, I've lost that working memory I've lost the context of what was on the first code sample. Did anyone write that down? No one wrote that down, because we're all at university. We're all 18. We're not thinking that we need to copy this down, because we don't know that that we're going to get copies of the slides. Or even worse, and this is from my perspective, my opinion, if a lecturer hands out the slides beforehand, why do I need to go to the lecture? Because I could just sit and read the slides, right? Because a lot of people fall into that trap of putting a million points on a slide and just standing there and saying, so slide 1 says point 1 is, and the compiler takes the code and produces object code, instead of actually using it as a prompt to remind them of what to say. It's all there on the slide. So I don't have to be at the lecture theatre, because I can just read the slides, right?
Yeah, and even if, imagine slides would be perfectly executed and everyone would pay attention, this is possible, then still you wouldn't teach something like error messages or making a typo, right? Unless you also put that on the screen. But then it's not on the slides, it's not so authentic. It's really authentic to see a teacher be confused in front of the classroom and see their solutions to that, their process of getting out of confusion. That's really something you get from live coding and you don't get from slides.
Absolutely. When someone is teaching someone else and provides a perfect example of this is what it looks like when you so let's step outside of programming, right? Let's say you're going to learn to drive, and your driving instructor says, okay, and so we turn the key and the engine starts. We put it into gear, assuming a manual transmission, take the parking brake off and press on the accelerator, and we start going. That's brilliant. But what if the car engine stalls when you turn it on? If you don't know what that means, you have no idea of how to get out of that situation. And if the car genuinely stalls whilst the instructor is showing you, you then get an insight into how to get out of that situation. I don't know if automatic transmission cars stall, but as an example, right?
Yes.
Okay. And that sort of debugging process is, I feel, almost as important as the programming, right? Because without wanting to sound horrible, it doesn't take comparing debugging to learning syntax. I feel like debugging is harder for most people, not for everyone, but for most people, than actually learning the syntax, right? Because you, given enough time, you can learn the syntax, but you can't learn debugging just by looking at the code, right? You need to actually get, as it were, get your hands dirty, get get into up to your elbows in the problem and figure out, right? Okay, maybe it is a missing semicolon, like you said, or maybe I've put a typo in here, or maybe the variable doesn't exist, that kind of thing.
Yeah, so I do agree that this is something you have to do, but I think what we sometimes mean by that, maybe not you, having read my book, but other people, is that this is the only way and the only act that you do while learning debugging. And there I think we might not be right. So as with syntax, you have to know where to put the semicolon. With debugging, there's also strategies that you can know about. And I was never taught any of this. I figured out all of this by myself and with friends in university. Strategies like, if code isn't working and a line gives an error, you can comment that line out. You just put two slashes there or a pound, whatever the language you're in. You can temporarily disable a certain line of code, and you can do that with a comment. And many IDEs have a shortcut to do that. I still see students in every line, like put a pound sign, and they do this for 10 lines. That's not effective. So I make them so much more effective. This is why I like teaching the IDE as well. I say, well, buddy, if you do control or command ? It does the whole block. And then, of course, it's not about teaching that shortcut, but knowing that really unlocks more debugging power, because if you can do a whole block at a time, then it makes you more quicker, more flexible. I can try this, I can try this. Other things like putting printf statements in a certain place to actually output something, that is valuable. I have many students at the end of their undergrad that they don't know debugging, but also they don't know the debugger. It's like, look, you can put a breakpoint there. And if you click the breakpoint, you can put a condition so that it only stops if a certain value is true or null or 0 or whatever. Those are all things. Yes, you can figure them out. Many people have figured them out sort of by themselves. But these are all things you can explicitly teach, and you can quiz students. Do you know the shortcut for this? Do you know how to set a conditional breakpoint? If I set a breakpoint here and now I run the code, can you predict what will happen? It's a lot better. We talked about that earlier in the episode. If you're debugging and also learning the debugger at the same time, maybe you remember nothing because your brain was so busy. You don't remember how to do the debugger, how to use the debugger, and you also don't remember what debugging strategy you are applying. So yes, it is somewhat true that it is a thing you can practice, but then probably the thing that you're practicing while you're doing debugging is not so much learning the techniques if you've learned them before, but more sort of getting comfortable with confusion and frustration, and training your stamina, because the first time your code breaks, you're like, help, oh no. And I have this with middle schooler, like, teacher, I broke the machine. It's like, no, don't worry, this will be fine, let's look at it together. So what you're training there is really your stamina for confusion, which is something that now, as someone with 3 decades of programming experience, something breaks and I'm still a bit like, oh no, something is broken, but then I can tell myself, don't worry, you've been here before, probably something very small is amiss, and I can tell myself that it will be fine. And I think that is the thing that, yes, you only get this by experience, by having been in a situation where you're like, I will never know how to fix this, and having come out at the other side. That's definitely something you can only practice with experience.
Sure. And I feel that, personally, I feel that when it comes to people who are at the beginning of their career, be that academic or like the academic side of it, or like the experience side of it, I feel like that can be helped by pairing them up with someone who is slightly more senior, but I feel like that's more in the workplace, because I'm not sure that happens at academia. Like I say, it's been years since I was in academia or any kind of code camp situation. So perhaps that a way to do that is to sort of get students to talk and exchange ideas, or maybe pair them up with someone who has a little more experience. But like I say, I don't know whether that happens in academia.
Yeah, I do think that happens, if only because the student numbers are growing everywhere, because computer science is a super hot topic to study. So I guess inevitably there's a little bit more group work just because it's practical. And we, like in the institution I work, we used to have 50 undergrads and now we have 400 undergrads. So yeah, there is a little bit more group work just because it's practical. And also, of course, students can learn from each other. Although, yes, sadly, my book doesn't talk about this. I wish there would have been more room and time to talk about it as well. But there is also a group dynamic there that at least you have to be aware of. Because, who is more likely to pick computer science in high school? Who is more likely to already have some knowledge? This will be whiteboards. And you really, I don't want to speak for everyone, but I don't want to be in a classroom where I make some groups, and in all the groups, it is the whiteboards that are explaining to the rest of the group what they already know. Because this might accidentally strengthen some stereotypes, right? Then maybe the people from other backgrounds, girls, non-binary students might be like, oh, they already know everything. So clearly this is not the course for me because I was already supposed to know all these things. And people like me don't know all these things. So maybe I'll just go do biology or, a study with a little bit more diversity in gender. So that is definitely something. Yeah, it's not an easy solution, but this is something at least you have to be aware of if you choose those assignment types where part of the group will explain itself to part of the group. That this will not be random. The prior knowledge will not be random.
Sure. Yeah, I fully appreciate that. And I guess that's one of the slightly more difficult aspects of, especially of teaching the skills, is how do I sort of group these students together such that none of that happens. And like you say, it's not an easy problem to solve, right? It's an NP hard problem, right?
Yes.
Excellent. Okay, so we talked a little bit about the book. What I'd like to do is give the listeners a bit of a flavor of some of the stuff that's in there. We talked a little bit about the theory about how there's short-term memory, working memory, and long-term memory. But let's say I have some code to learn, or I have some. We'll come on to code to write in a moment. But let's say I have some code to learn. Do you have any effective strategies? Let's say I've never seen this code base before. All I'm looking at is one function. It's about 20 lines long. It does something that, to me, immediately, because I've never seen it, is rather complex. Mm-hmm. I know about short-term memory, long-term memory, working memory. I know that working memory is, like you say, it's kind of like my processor. I'm going to be pulling information from here, there, and everywhere and sort of combining it and working on it all. I know that my long-term memory is things where perhaps I have my experience, or maybe I have a little bit of knowledge of how this language works, or I have a little bit of knowledge of what I think it's supposed to do. I'm understanding from our conversation that short-term memory is where maybe the code I'm reading is living. Is all of that correct? Am I barking up the wrong tree? Have I got it completely wrong?
No, absolutely not. So the first thing is that it's interesting to understand what is your prior knowledge. So you're saying, I have not seen this code base before, but that's not the whole part. So first we want to understand, do you really know the programming language intimately? So one thing on my checklist would be, do you really understand all the syntactic concepts that is there? Do you understand the separate parts? Right? And there might be a for loop and an if statement and some initialization code. You don't know how it all ties together, but at least do you understand the individual parts? Because if this is the first thing that you're, well, I don't want to say failing, but information that you're lacking, then it makes not so much sense to continue. Then really you first want to understand what is the syntax that I'm using. And another thing is, like, what is the domain? So it might be that this is a part of a code base that you work on and you know what everything is. Like there's, I don't know, a customer and an order and an account. Let's take a very simple example that we talk about. Do you know what all these words mean? Or is also the domain foreign to you? Because if the domain is foreign to you, you know the programming language and you know the concept, but the domain, you don't know exactly, what is it that, what does it mean that someone has employment? Is this temporary? Should there be an end date or a start date or a salary? So that's the next step is, do you understand all the domain concepts? If you don't, if there's words in there where you don't exactly know what they mean in this context, and that is also something you want to fix before. And that ties into your final question. You're like, is all of the code in your short-term memory? It depends. That's the confusing thing, that if you are an experienced C# developer, then something like for each customer in customers, surrounded by round brackets and then curly brackets, and then something is done over the customers. To you, this is like one block. You look at it and you immediately say, oh, someone is looking over a list. But someone that might be coming from Python or from C, in which there's not really for each, but it would be for I smaller than the length of the list, and then you have to also get customers at the location I, rather than looking over the customers directly. Maybe this isn't one chunk, one unit of information. Maybe this code doesn't fit in their short-term memory. So you can only get big blocks in your short-term memory if you really have this prior knowledge. So that would be my advice, which is, again, that's not a thing that we commonly do. Examine our prior knowledge and append it if necessary. It's like, oh, let's run the code. Oh, I don't understand it. Let's run it again. That's basically the tools we have. Let's use the debugger and step through it. Let's put some print statements in places. But yeah, there are other things you can do, like critically examine, what do I already know? What knowledge do I have about the elements of this code?
Excellent. I like that. And what's great about that is hardly any of that is related to actually solving the problem of putting whatever new statements are in there, right? And only one of those things actually requires knowledge of the language itself. You were saying there, do I know the syntax of the language? Maybe I don't need to know so much of the syntax of the language if I understand, like you were saying, the context, the domain, what it's expecting to do. For instance, my friend James, he last year became a Python developer, had worked in .NET for something like 12, 13 years beforehand, knew nothing of Python, but fell into it because he understood the domain that he was trying to solve in the project he was working on. He understood the context of what was happening in this code base, and was able to learn the bits that he didn't know as he was going, right? You were saying there about, do I understand, there is a for each loop. If I'm not a C#.NET developer, I may not know what a for each loop is. But if I can find out, right? And if I can find out what that means that chunk of code then becomes not immediately not mysterious. That's double negative. I do apologize. It doesn't stop that code from being mysterious. It makes it less mysterious. I understand now that this is looping through this collection and doing something to it. Whereas previously it was, here's 4 lines of code that I don't understand, and I'm going to sit back and panic, like you were saying earlier.
Yeah, exactly. Yeah, we really found this. So one of the things that I'm involved in is called code reading clubs. Maybe we can put a link in the show notes. And this is where we get together monthly with people that are interested. And together with a group of other organizers, we take a random code snippet, something from GitHub, and we read it together. And indeed, very often you see, and we always pick different languages, very often languages that we are not familiar with ourselves. Sometimes we don't even know what the programming language is. But even not knowing that, if you know a bit of the domain, if you gain an understanding of what's more or less there, then you can still read code if you don't understand the syntax, because also many things are quite similar, right? So if you understand the structure, the concepts, and the context, the domain, then you can fill the syntax gap. And the other thing is also somewhat true. If you really know the programming language very well, and all the variable names are a bit weird, or maybe written in a foreign natural language that you don't know, then you can fill those gaps. But if you are in a situation where you don't know both, you have little chance of leaving this code base with an understanding.
Sure. You need a foundation of knowledge. It doesn't have to be the syntax. It doesn't have to be the language. It doesn't have to be the context. It needs to be something, right?
Yeah.
That's my opinion, and based on what you were saying. A friend of mine once said to me, you need a solid foundation of your knowledge because you can't build a house on sand, is what she was saying.
This is very true.
Mm-hmm. And without that sort of base level of some knowledge, it doesn't, like you were saying there, it doesn't have to be the language, doesn't have to be the context, doesn't have to be the domain, but it kind of has to be one or some of these. It needs to be little bits. And then, like you say, you can fill in those gaps, right? Excellent. Okay. So one of the things that I really like that you'd said there, and something that you mentioned in the book, is reading code. And I feel like a lot of developers don't actually go out of their way to read other code, be it in the code bases they work in, be it in a language that they work in, be it in a problem domain that they work in, or be it completely outside of that problem domain. I recently was really enjoying, a number of weeks ago at the time of recording, one of the podcasts I listened to called Coding Blocks had a game jam. And what they did was they got anyone who was willing to do it was encouraged to live code on Twitch the game that they were making
Cool.
in the 48 hours that they were doing it in. And some people were choosing languages and frameworks that they had no idea with, they have no experience with, they've got no idea what they're doing. That's unfair to say. I don't want to say they don't have an idea of what they're doing, but you know what I mean. They're new to the language,
Yes.
they're new to the framework.
Yes.
And some people who were games developers were saying, well, I've done this in C, C++, I've done it in Python, but what about if I try it in JavaScript? And they
Yes.
were doing what you were saying there. They have the context, they have the domain knowledge, learning a new language, or they have the language knowledge, learning a new tool, learning a new framework. They have that base level of knowledge to sit with. And I feel like in order for them to take part in this, they were reading through code and learning new stuff, learning new techniques, learning new technologies. And I think that that is something that a lot of developers, at least in my experience, don't tend to do that often. Oh, I'll go on to GitHub, like you were saying with your code reading club. Let's go to GitHub. Let's grab a random file, maybe not even the whole file, just this method, and see if we can figure out what it does. And I feel like not enough developers do that, I think.
Yes. Yeah, so that has to do with many things, of course. Firstly, it is, again, we don't really practice this. Many of the things we do as a community to get better are also emphasizing writing. So like, oh, do you want to learn Rust? Well, why don't you make this little to-do app, right? No one says, oh, if you want to learn, maybe you read some code snippets. So that is definitely part of it, but it also has to do with like the reward structure of if you do this, imagining you do this in your paid work time, right? Then maybe there isn't even time for refactoring. Maybe there isn't even time to write documentation because your boss is like, ship the thing. So carving out space for yourself to learn new things can be really, really challenging. And typically that takes the form of going to a workshop, going to a conference, ordering a course, reading a book, but really saying, oh, well, I'm going to practice code reading deliberately. It's just not something you will get immediately rewarded for. And also you might not know how to do it. Like my book offers a little bit of tips and the Code Reading Club resources have a bit more. But imagine even you would want to do that. Well, okay, you go to GitHub and you type to-do app in Ruby and you find code. Now, okay, so what do you do, right? What are the techniques that you can do? How do you know when you're done? Like when, well, okay, I sort of know what it does. Have you quiz yourself? So even if you want to do this, which doesn't really fit in the way of teaching and learning that we all sort of believe in, then it would still be quite hard to do.
Sure. And I guess if you're doing it yourself, like you were saying, right? If I go to random GitHub repository, random file, and I think today I will learn what this function does. It is in, like you said, maybe it's in Rust, maybe it's in Go, maybe it's in Ruby, Python, whatever. Today, my goal is to learn what this method does. How do you know that the method does what it does?
Yeah.
Right?
And also at what granularity, right? Maybe the method is called analyze. And you could say, well, it analyzes things. Maybe the parameter is called data. It analyzes the data. I am done, teacher. Give me a sticker because I solved it, right? So there's always this, and for some context, this might be enough, right? If you're reading code because you're like, oh, I want to figure out how this API works because maybe I want to use this to analyze the data, then maybe it's enough for you to know that the method is called analyze and the parameter is called data, and that's what you put in. So it also really very much depends on the goal. And sometimes you're reading code to decide, do I want to use this library? Like you're sampling a number of, I don't know, JSON parsers or something. You're like, oh, which of these? Then the questions you're going to answer is, what features does it have? Maybe you look at the GitHub repo, like, is it under active development? That's also reading. But that's a different form of reading where you're like, oh, I know there's a bug because I got a runtime error in this method, and now I have to figure out why. I'm reading the code for that goal. Yeah, those are really, really different goals that are going to need different techniques.
I agree. And there was a technique that you point out in the book, and there's multiple parts where you talk about this, where you say, let's take some code, let's print it off, and let's actually annotate the code. Let's go through and say, this is a variable, this is a for loop. This chunk here I understand because it's printing to the screen, or maybe it's doing, it's talking to an API, or maybe it's parsing some data. Just I'll skip over that, and that way you're reducing the amount of code you're having to read by doing the exercise that we talked about earlier on. You're looking at some code. There's a for each loop. If you know what a for each loop does, you can almost step over that and ignore it and focus on the parts that you don't know. And by maybe circling things or writing little icons. And I love that you have a set legend of icons that you use for this is stepping through something. This is something I need to learn. This is a for loop. This is an iteration. I really like that because then whilst I'm not a visual learner, it makes it obvious as soon as you look at the code. If it's got these icons on it, or maybe you're using highlighters in different colors, you can see immediately. It's no longer black and white. It's multiple colors. There's lots of different icons. There's annotations everywhere. This does this, this does this. It's almost like what commenting is kind of meant to do.
Yeah, so that's an interesting point. I've brainstormed about that a lot with myself also. That, why doesn't an IDE let me do those things? Why can't I draw on top of code? I can put an arrow there and then it stays there. And maybe this is a layer I can turn on and off. That doesn't seem like something that's spectacularly complex to build. So for the code reading clubs, we've made our own code annotation tool. But then this is not an IDE. This is just you open the code in a browser and then you can draw arrows and you can make colors and this is all nice. But then this is the browser. So it doesn't execute your code. It isn't connected to anything. Why is documentation so limited? And why isn't like you have, this is like one of my dreams. I'm just going to put it out there so someone can build it for me. Why do we use commenting to disable lines of code, right? So if you're debugging, you might just want to say, I switch this line off. And then we do this in this very, I think, ugly and confusing way by putting a pound sign or 2 slashes there to make it into, but this is not a comment. It is not a comment. What I want to do is turn this off and then turn it on. And that's really a different thing than putting a comment there. But because we never think about code that way, or we think it's not very hard, we sort of fall back to something that really, it isn't what it's meant for. And then also I think this is not hard. Visual Studio, people at Microsoft, if you're listening, in the gutter, you can just put a check mark. And then if the check mark is not on, you don't execute the line. You don't you can even secretly just put 2 slashes there and don't show me. This would be so easy. So yeah, why are IDEs so boring? Why don't they let me draw on top of my variable? Why don't they let me highlight stuff? It's really not that big of an ask, I think. But yeah, apparently maybe I'm the only one that wants this, because if it's not there, maybe there's not a market for it.
I like the idea that you mentioned something there, and I'm going to infer from it. So I'm taking what you've said and applying my own opinions of it. Why is documentation just text? Right? We have UML diagrams, we have all sorts of Visio diagrams and things like that. Why is it just text? Right? Why can't it be?
That's a great question.
Yeah,
and then you can talk about documentation that is separate from the code, like a markdown file, but also in code, right? Why can't I put a little balloon there or a warning? Like, if you reach this code, warning, you might be tempted to turn this variable to true. Don't do it.
Yeah, right. And I can imagine that, let's say we fire up whatever IDE we're using. I'm a junior developer. I'm looking at a huge code base, and it's just a wall of text. And guess what? I'm using a large monitor. I have like 400 pixels to the right of that code, assuming a left to right culture. I have 400 odd pixels to the right of that code. I've got loads of space. I can make all sorts of notes there. Or indeed, you talked about being able to disable a line. If I can draw on the code base, perhaps I can scribble over the line that I want to disable. And the IDE goes, hey, you've scribbled on that line. That in human, if I'm writing something down and I scribble it out, that means ignore this line, I've made a mistake. Or I ignore this word, I've made a mistake.
Yeah.
Perhaps we could scribble over the statement and the debugger will go, that statement doesn't exist, I'll just jump over it.
Yeah.
Like, why not, right?
Yeah,
It
there's
makes
so
it
much,
a little more
if you're in this fantasizing about the future of IDEs line of thinking, then, why does everyone look at the same code? I am logged into Git. So my Visual Studio knows who I am, knows what lines of this code base I have touched in the recent future. So maybe if something is very new to me, maybe I need a different presentation. Maybe if I'm scrolling to a piece of the code that I haven't touched in forever, or maybe I've never seen, my IDE can know this. It can go to Git and it knows if I've ever seen this line in my life or not. Maybe, like, the most boring thing you could do is maybe make it more red if it's more unfamiliar to me, so that I realize, like, oh, this is maybe a part of the code base I'm not so familiar with. Or inline a few methods to make it easier for me to read this. So you can do so much manipulation. And I'm like, this information is right there. Mm-hmm. I don't know why IDEs are the way they are. They don't have to be.
These annotations that we're talking about, maybe we're drawing on it, maybe we're writing on it, even though the code is checked into Git, something in the IDE, something in Git, I don't know, something could say, this is Felinne's annotations for this code. I won't check those in because these are for Felienne. These are Jamie's annotations. I won't check those in because I don't want to affect the committed code in the repository, but I will allow them to stay local because they are Felinne's notes for how the code works. That way, Felienne doesn't have to keep a separate file with all of these in and keep those up to date. I, as the IDE, can store this as, so for instance, Visual Studio Code has a separate directory for all of its stuff. So if you go into a code base that has been manipulated by Visual Studio Code, there's a .vs code folder. If you use JetBrains Rider, there is a .idea folder. If you use any of the JetBrains tools, they do this. And so Visual Studio could also do the same thing, .visual studio or something, right? Because for those who don't know, modern operating systems, if you prepend the name of a folder with a dot, it will be hidden from view. And so you could just, and then you add that to your git ignore, or maybe it just does it automatically, and you don't have to worry. Anything that is in there is local to you, and then your annotations, your I'm worried about using the word doodle, but your drawings, your notes that are placed on top of the code for you by the IDE at display time, I guess, are then stored locally, not pushed to source control. And that way you don't have to worry about, oh, well, my notes are polluting everyone else's notes. You don't have to worry about, well, this developer on the team doesn't like to have those visual styles of notes, so they never have to see them. Like, what, I agree with you, Felienne. Why doesn't this exist? I agree with
you. This is easy. Why don't people build this? You know what I mean? Exactly. I know everyone's busy and everyone has nice ideas. It's probably not so easy as we think it is. But there is something there, I think, where the things we do, we talk about in the book, it is sort of weak because there's nothing else. So we say, okay, print out your code and then circle the variables there. And many people ask us, I would prefer to read it in the IDE because I have syntax highlighting and then it can be saved. It's like, yes, I get that, but it is now either it's in the IDE and then it's executable, or it is on paper or on the tablet or in the annotation tool that we use in the browser. There you can do the drawing, but then you lose the execution and you lose also your GitHub history. Yeah, you also lose things. Yeah.
Mm-hmm. And I could imagine that it would be useful during a debugging section, right? So you've got the code running, you're debugging, and you're like, right, I need to write this down. Okay, I will turn away from the computer, get my pen and write it down on a piece of paper. But then, like you say, I've lost the debugging context.
Yeah.
If I could have a separate set of annotations for when I'm debugging this method, show me these annotations. Right, okay, I'll write on the screen, when this integer is 7, the program seems to break.
Yeah. And then, even if you're not the type of person that wants to see other people's notes, maybe one day you're in the situation where, oh my God, I have no clue what to do. I'm so stuck. Maybe that is the moment that, okay, let me see all my friends and colleagues. Let me see their annotations because maybe there's something there.
Mm-hmm. And that could end up being a sort of living documentation, almost like a training for maybe you bring a junior developer on and you say, right, this method, just look at all of these annotations, right? It is difficult to read. Don't worry about not being able to understand it because everyone has lots of annotations in this.
Yeah.
It doesn't pollute the code base that is built by our build server, but it allows you to see, look, there's a bubble here that says, be careful of this. Here, put a print statement here if you need to debug it, that kind of thing.
And it might serve as so when we talk about code reading, we're always talking about, okay, where are we going to read? Not if it's one method, but if it's a repo or a bigger class or a few files, it's always like, what is a start? And sometimes you're searching for like a main method, like an entry point. But another thing is you can also look at where's complexity. Where is a variable that is used in many different places? That's one of the annotation exercises that we have. But you could also then look at the bubbliness of the code. So if you have this new code, then you say, okay, where were there many annotations made? Maybe this is an interesting place to start, or maybe it's an interesting place to avoid, because maybe that's too much complexity, but at least this could also be breadcrumbs that you leave for others.
I like that, because then that allows you to do targeted code review and say, hey, this chunk of code has the most annotations. Perhaps it's the most cognitively complex. And so maybe this is where technical debt exists.
Maybe this needs a refactoring, if everyone's dealing with the same thing. If everyone says, well, it took me 5 tries to figure out that, I don't know, this is actually async or something, then maybe we can put this in a variable name. Maybe we can put this in the documentation.
I like it. Let's make the code better by doodling all over it. I like it. So with all of that said, so one of the things that's in the book is all about writing code, not just learning other people's code, but writing code such that it is easier for other people to understand, right? And I think that this specifically is an NP hard topic, because like you were saying earlier on, you've got you may not have the syntax context, you may not have the domain context, you may not have the context of the outer context in which this code is executing. There's so much knowledge that you have to assume when going into a method, a function, an API space, a class, or whatever chunk of code. For instance, I'm not an operating system developer. If I go and download the Linux source code, I am going to be lost. I have the C background, but not to the level that Linus and the other Linux developers have. So I don't have the context of how a kernel of an operating system works, but I have a little bit of context of how C works. And so I can maybe fumble my way through. Maybe I'll look for that main method. Maybe I'll look for a particular API space. I do have somewhere a 4,000 page book that is learning the Linux kernel. And I got about 4 pages into it and put it back into storage. But I guess and then on top of all of that, you assume that everyone speaks the same language, right? Programming languages are in, like C is in C. JavaScript is in JavaScript. English is in English. French is in French. And so you're assuming that all of the I guess, cultural context that comes along with that particular language, and perhaps the problem you are solving, is coming with it. So I guess, how do I write code that other people can understand? And like I said earlier on, other people could be me 5 minutes from now.
Yes, I like that. I always say that there's no such thing as clean code, right? It doesn't exist, because the only thing that we have is code that is clear to a certain person at a certain point in time, right? If I write something very clever, it's like, oh, look, all my methods are very short and there's not too much parameters and all the stuff that people like in their not smelly codes, and if I forget everything. So there's a few aspects to this. Firstly, I think you have to understand, like, clear for who, because it isn't going to be clear for everyone. And I really like that when I was writing the book for Manning, that they have this concept of a minimal qualified reader. So they say the person that's reading your book, you may assume that they know this and this. And you can pick this yourself. You write this little profile of, well, the person that reads my book, well, they know maybe 2 or 3 languages, maybe have 5 years of experience. And I think it's a really good idea for your code base to also think, okay, what can we expect? What are the people we're hiring? Are we really only hiring people that know, well, in your context, maybe C#? So then let's assume that people are familiar with most C# things. This is something we write down. We're going to assume that people know this. If they don't, and we still onboard them because, we need developers, then this is something we must make sure that they know. Do we accept or expect that people know the domain? If they don't, well, okay, that's fine. But then this is like the prior knowledge you need to have. So I think that's definitely something that in the code base, I work on a programming language for kids called Heady. And then I always think, okay, my minimal qualified reader is undergrads, because regularly undergrads, contribute to my project. So I want to write it in such a way that it is somewhat reasonable for them to join. So I think this is a good thing to have. And also I think that a benefit of reading a lot of code is that you put yourself in the place of the reader all the time. So I guess that, at least it has been my personal experience and that of other people that do a lot of code reading, is that then once you start writing, you still feel the pain of being confused. And then you're like, oh, let's not do the clever thing. Because I'm so often in the shoes of the reader, let's make it a little bit more explicit. Let's give this, like if you have I-1 as an index, why is it shifting 1? There is a reason. Can we just say system X uses 0 base and system 1 uses 1 base, so we have to do a shift here. So it's little things like this. You get more awareness for the little things that trip you up if you do lots of reading. So that will also help you. Not directly. It's not like, oh, now I have a skill I can apply. But that mindset of reading a lot of code, that will also definitely help. But it also just really helps to think of, okay, who am I going to expect to understand this? Because it's not everyone will understand. It's fine if you have this C# code base and you think, well, a Java developer that doesn't know the domain, maybe for whom English is not their first language. Yeah, okay. Well, they have no chance reading this, and that's fine. And they first need to learn the domain and C, and also improve their English. Yeah. Explicitly making it clear who you're optimizing for can be really useful.
Yeah, I completely agree with that. I think there's something that I feel like we've both said, and that is to go read code as part of your being better at writing code, right? There's a lot of novelists say that before I write anything, I go and read something. They read other authors to get maybe ideas or inspiration or if let's take a step outside of programming and say that you are a novelist. If you are a novelist who writes crime novels, but you want to write a fantasy novel, you can't just right now I'm a fantasy novelist.
Yes.
You have to go and read other fantasy novelists to understand the tropes and the formatting and how it all works before you can write your own. And as a C developer, as a Python developer, you have to go read other C and Python developers to figure out how other people are doing things, so that then you can take those ideas or maybe not take those ideas, right? We're talking about taking the best ideas. Maybe the code you read that is external to you is written in a bad way. You can also use that to reinforce your practice to say, hey, don't ever do it like this, because this is bad.
Yes, yeah, for sure, yes. And this is something also we experience with code reading clubs, that discussing other people's code is also a nice way to discuss design decisions. So what we see often is that many teams, I would say my own team included, we didn't set explicit design goals for how we would do the code. It's also hard if you're starting a project and you don't really know where it's going. However, what then happens is that someone makes a pull request. I look at the pull request and I think, this is not what I want. This doesn't fit my design. But then the design isn't anywhere. It's just in my brain. So then they give feedback to this specific code. I'm like, no, I don't want this. I want the data more centralized or something. But then this is a tough discussion, because now we're having two discussions. We're having a discussion, what does our ideal design look like? And also, are we accepting this pull request? And there's always one person whose pull request it is. So they have skin in the game, and that's really hard. So what I've also found is that if you do code reading as a team on code that isn't yours, then you get this really nice space to discuss things. You're like, hey, this method has 17 parameters. Is this something I like? And some people might say yes. If they all go together, if it's one block of information, I don't care if it's 17. I'd rather have it together. Other people might say, no, it's just 5 lines of parameters. I don't like this. And then you can just discuss that. And there might be difference of opinion, but there's no code that exhibits that difference of opinion. So that is also something I found to be really, really valuable, that you get these discussions about how do we want code to look like without talking about your code. And then you come to sort of an understanding. And also, so you talk about prior knowledge. Some people say, oh yeah, but maybe you didn't realize this, but I used to be a Java developer for 5 years. So I always have this little bit of Java to my C#, even though I know C#. That's also good to know, because if you know that, then also you place certain things in a certain context. Maybe they struggle a bit with exceptions because Java has this weird checked exceptions thing. And so maybe this will always be a little bit confusing to them because they have their Java background. So yeah, those are all reasons that are good also to read code independently from you get better at the skill of reading code.
I like the idea that you mentioned there. I'm going to use a phrase, and I hope that it sort of fits, is if you're reading code as a team and you're reading code that's not yours, you were saying there it provides almost like a safe space to discuss these things, right? You're not having to worry about, I'm submitting my code for all of my peers to criticize, because you may not be comfortable with that. It could just be, we'll just pull some code from, maybe if I'm a .NET developer, we'll go to the source code for .NET, talk about one of these methods, and we'll say, why do we think that the Microsoft engineer who wrote it this way? And then we'll have a discussion.
Yeah, and that's also nice. You get this really nice understanding that there's always a trade-off. And, I appreciate many books. Like, I love Fowler's book on refactoring and code smells. I think it's really good and it has influenced my thinking a lot. But it is a little bit like, this is correct, this has a code, and this has a code smell, and you have to do the refactoring, and then it is correct. Whereas there's always a trade-off. It's always a matter of what are we optimizing for? And sometimes you are in a hurry to deploy something. Or sometimes you have a bit of a weak, brittle understanding of a domain. Do I have the time to go over that? Or do I think, well, it will be fine. So I think that it's not easy to have these nuanced discussions. It's always very easy. It's easy to say your method is no more than 10 lines. If it is more than 10 lines, I don't accept it. This is easy code review, right? This is easy rejection. But then there might be good reasons. And I think it's always very hard to have this discussion, exactly as you're saying, on someone's code. And it also can be very ineffective. So if someone adds a feature in a way that I don't want, like I'll give you a concrete example. So we have a programming language for kids, and it is you are able to localize it. So you can put keywords there in Dutch or in French or in Spanish or in Hindi or in Chinese. So the first implementation, someone comes into my code base and says, I made this thing where you can localize the keywords, which we didn't have. I'm like, yay, I love that feature. But then in all the files, they copy-pasted the French words everywhere. So I was like, yes, I want to have this feature, but not in this way, because I want to have it in one place, so that's easier to translate. I cannot expect a French teacher to go into 12 files to make changes. So then we had to reject this pull request, and then the guy said, well, yeah, I don't have time to do it the proper way. If we would have had a discussion about how do we want to have this architecture together, or we would have written down this is what we want, then they could have done it right, whatever right means, like more in line with what I wanted in the first place, and then no one's time would have been wasted. And I think this is true for many pull requests, maybe especially in open source, where people are like, I have a problem, I will fix the problem. But they don't do it in a way that fits, and then the project is like, yes, but no, and then no one leaves that interaction happy. Everyone is basically sad in such an exchange.
Sure. And I'm also seeing the discussion of some external party's code as a team is a collaborative effort, whereas I feel like a pull request is usually a one-on-one. You were talking there about this engineer who had implemented this ability to translate all of the keywords, but it was from what you were saying, it was you and this other developer.
No.
Unless I dive into that pull request and read through the comments and the discussion that you and the other developer had, I have no knowledge of that. It sits external to my thinking process.
Yeah.
Whereas if you brought a team of people together and discussed it first and maybe stored it somewhere, there is that discussion that happens between everyone on the team, and then perhaps you can then take the outcome of that meeting, the outcome of that discussion, and roll it into your coding standards for the code base that you're working on. So then it becomes almost like a concrete rule, right? We discussed on March 12th this thing. We talked about this code base. Here are the annotations that we made as a group. See, all comes back to those annotations, right? Because there is a precedent for that, right? If you look at the pull request tools, you can make annotations on individual lines of code, and it doesn't affect the line of code. All right, it's in it is a text box, and there's a little bit of highlighting, but I've looped back to it because I've just realized that there is precedent for it in the pull request tools that we have. If you look at GitHub,
you could just from your IDE, you can grab all of the discussions on a certain line. Yeah, and I think it would be a really good onboarding activity as well. If you have a new developer, and in their first week you take random code, not from your code base, and you go over together. It's such a good way for that person to understand everyone's background, and for you all to understand that person's background, and to also discuss things like, do you like this method? And then you can, well, I don't want to say like push your rules on them, but at least they can see, oh, this is how people generally think about things, and take that into account if they start writing code.
Absolutely. They get a feel for like the community that they're working in, right? I've forgotten the word now. A lot of business types talk about it. When they bring someone in, they need to make sure that person fits the style, the
culture?
group, the culture. Sorry, yes, the culture around the code. Right? As a junior walking into one of these meetings, it may be a little scary because you're surrounded by seniors and you're worried about your opinion not mattering. But guess what? Your opinion matters, right?
Yes.
But also, you get a feel for the culture of how the people around you are writing code, so you know that it's okay to write a method which, I don't know, instead of, let's say you're in .NET world, sometimes it's better to do a for each over a collection than a for loop and index, or array index things. But for some reason, the culture of the company that you're joining, maybe we don't really like for each because of X reason. So please make sure that you write it with a for loop and iterate over it.
That's such an easy intervention, right? And that saves them from having their first pull request or whatever you use, their first code review, like being bad because it's like, oh, you didn't do this, and then they couldn't really know these things.
Mm-hmm. I like that. And it's a lot better than so some of the companies that I've worked in, when I've transitioned to working there and being onboarded, it is just literally, here's a code base, go read it. Now that you've done that,
or here's a bug, can you fix it? Or here's a feature, can you just add this feature? Like, I know I'm raising my hand, but you don't see this on the podcast. I'm raising my hand to say, I have done this to new contributors. I'm like, well, welcome to this code base. And then people are like, how can I help? I'm like, well, here are 5 open issues. Let me know when you're ready, which I understand now is maybe not the best way to make people feel welcome, but also not a good way to imprint upon them the culture that we care about in the team.
Mm-hmm. Yeah. And I suppose that then becomes a little difficult if you are a distributed team, right? Let's talk about Heady, right? I'm assuming Heady source code is on GitHub or similar. If the entire team is distributed, how do you bring people together to figure out that culture, right? At least in a team situation, be academic or in industry or whatever, you can, even if you are remote, you can fire up a Zoom, a Google Hangouts or Teams or whatever, and get everyone together in a certain time zone and say, look, okay, so today we're going to talk about this thing here. Why do we do for each instead of for? Why do we do for instead of for each? Why do we never do while? Why do we do while? Why do we use revealing module pattern in our JavaScript rather than some other pattern? And then it can be discussed. Whereas if you are a globally distributed team working in open source, I guess that's a little harder.
Yes, and our context is specifically complex because we have people that I pay to work on it because we got a grant from the Dutch government to expand Heady. I work on it. We have open source contributors that volunteer and work for free. And we have students in the university that have to do a closing project for their undergrads. And then they choose to work on Heady. So they are not volunteers, but they're also not paid. And also their goal is more learning than contributing. And then I am in the sort of power relationship with them because I'm also their supervisor and I'm the owner of the code base. So our team dynamic is pretty complex.
Excellent. Okay, so let's talk about Heady then. You've mentioned it a few times. It's a tool for high schoolers, is that right?
Yes, it's a tool for high schoolers. Yeah, middle school. So our high school is different. In my country, high school starts at 12. I appreciate the fact that this is different in different parts of the world. So let's say the age range, so it's clear to everyone. So we aim at the age sort of between 10 and 14, which for in my country is high school, but maybe in yours it's not.
Okay. So I guess what is Heady then? You've talked a few times about you've mentioned that you could translate keywords. So I'm guessing it's a programming language.
Yes.
Okay.
Yes. So it's a programming language for kids. And if people have already read the book or parts of the book, then they will see that the book and Heady very much lean on the same foundation. The idea is, we talked about this a bunch of times already in this episode, that if you have to do many things at the same time, it's really hard to remember. So if kids come into programming, specifically textual programming, kids might come from block-based languages like Scratch or pencil code that are very friendly and colorful. Oh, you click stuff together. That's typically very well for this 8, 9, 10-year-old range. That this is enjoyable and they get their first steps in programming. But then after a while, they want to do grown-up programming, right? If they are 11, 12, it's like, oh, we don't want to have toys. We want to have authentic programming. And this really also fits with what we know from that age group that once they start to become in puberty, then they want to be grown-ups. That's what I want to be. So they want to have a textual programming language. But then that transition from something like Scratch to Python is very heavy. Just if you want to print something, you have to do print, open brackets, quotations. Hello, everyone. Quotations, closing brackets. And then what do you have? You have text on a screen, right? With Scratch, you have a cat that is dancing with the same amount of effort. So when I started to teach this age group, I found that some kids sort of make it. They figure out how Python works and they're happy, but some kids fall in this gap because they don't see where it's going. They don't see the value. They want to have this authentic thing, but then still interest and motivation only lasts for a few hours. If you don't have any clear goal, then where this is going, then still you're like, why am I doing this? So the idea of Heady is that we gradually introduce syntax and concepts. This is why we call it a gradual language. It has different language levels. So the first level, you can print something and you just do print, and then you just do hello, Jamie, and then it prints hello, Jamie. And no quotes and no brackets, nothing, no syntax apart from the word print. And then gradually we add things. So in the second level, we add variables. So then you can say name is Jamie, print name. And still no quotation marks and no brackets are needed. And then of course, you do run into issues because now name is defined as Jamie. So if I want to print, hello, my name is Jamie, this is not possible because name already has a name because it's Jamie. So then we say, hey, look, oh, this is sort of inconvenient that this word that is a variable now is now blocked. So if you would just have a way to distinguish between variables and text, well, that's a quote. So then we introduce the quote in a way that has meaning. It is interesting because I have told kids, and then maybe you did as well, where like, teacher, why does a quote go there? And you have to say, yeah, don't think about it. Just put it there because I say so, which I don't think is a really great way of teaching. But then again, it's also very hard to explain to this kid. Well, imagine that we didn't have quotes then. The computer wouldn't understand. And you have to explain all of the stuff to them that they don't know. So that's the idea of Heady, is that every level we gradually add syntax and we add concepts. And then the end of Heady is actually secretly Python, not so secretly. Then at the end of Heady in level 18, you're programming in a subset of Python. Not everything, so no functions, not OO, but you do know ifs and booleans and while loops and for loops and looping over a list. So you have an understanding of most of the concepts, and from there, you can merrily go your way to do actual Python. And then one more thing that's really cool about Heady, which we didn't have initially, but we just added quite recently, is the ability to indeed localize to different languages. Because we did an experiment with Dutch kids, and we thought, yeah, Dutch kids pretty good at English, probably will be fine. And they're like, no, we want to have Dutch words as keywords. So we now allow for Dutch and other languages. Well, we have Arabic, and we have Hindi, and we have Spanish. So you're allowed to use, instead of the English keywords, also keywords in your own native language, which clearly, again, greatly lowers the barrier towards adoption. Because if you tell to a kid that's coming in from a country where they speak and read Arabic, in Scratch, you can have Arabic and everything is right to left. And then the kid is like, okay, now I want to do a grown-up language. And it's like, yes, this is fine, but it will have to be in English and also left to right. And the kid's like, okay, but where is the P on my keyboard, right? I don't even know how to type these letters or pronounce these letters. So if we want to be more inclusive, then it's definitely important that we also have this localization.
I really like that. There's a whole bunch of stuff that you've said there that I really like. I like the idea of graduating to a grown-up language. I'm throwing the bunny quotes there, just like you did. I love that idea of slowly, because I've taught the kids. I've helped the kids to do Scratch, and yeah, it's great. It's a brilliant visual tool. You drag and drop, and then, like you say, you have a cat that's dancing, and it's brilliant. You've gone from nothing to something, and it's in a way that you don't need to know syntax. You don't need to know what you're doing. You could slowly introduce whiles and ifs and things like that. But how do I put it? I don't want to be exclusionary, but you're like, they would say to me, "This isn't real programming, though, is it?" Right?
Yes.
And I would show them some code, and they're like, "Oh, this is bamboozling. I may as well have shown them a novel in medieval French,"
Yes, yeah, and this is exactly the gap that we aim at. Like, Scratch is great for this initial learning. And actually, I think in terms of just the content of Scratch, and there's also Snap, which is like Scratch, but for slightly older kids, that's very powerful, that allows you to create your own blocks and higher order functions and everything. So, like, didactically, there's a lot more to be learned from kids, but pedagogically, they push back against these baby blocks. This is a toy. This is what my baby brother does. And then, of course, you can, and I have tried this, you can tell a 13-year-old, no, it's not a toy, because actual programming, because it has the same things, because C or JavaScript, it also has an if, and it also has variables. No, it's really, really the same thing. It just has these colorful blocks. But they don't want to have a little wooden hammer. They want to have a proper hammer and make something real, or they don't want to do little finger knitting. They want to do actual making something with real tools. This is like a part of growing up, and battling that, it has been my experience. It's just not so successful if kids don't enjoy something, if they don't want to learn. Then that makes it hard. And also, so if a kid wants to learn programming, then maybe Scratch is fine, because it's clear that there's some programming concepts there. But I teach in an inner city school in one of the poorest zip codes in my country, where many of the kids come from lower socioeconomic backgrounds. They don't want to do programming because it's interesting. They want to do programming because it's good money. And what they want is to provide for their families and have a good career. And they know that, if I become a programmer, then maybe my company will give me a Tesla, right? And 100,000 euros a year. That's their motivation. And then showing something to them where it's very clear that it's not career potential. Like, there are no professional Scratch developers, even though maybe with low code and no code, this will be different, but I think that will take a while. So you show them something that doesn't align with their reasons for learning programming. And they're like, I'm not here to get a toy. I'm here to get employable skills.
Sure. And I guess along with that, there's a quote from Jeff Atwood, I believe, where he said, "The user interface is the app." If you, if you show a student Scratch code and they're like, "It's great, but I don't like colorful blocks. I'm more grown up than that," and you say to them, "Yes, but it's actually doing programming on the other end of it," they're not seeing the other end. They're not interested in the other end. They're interested in what they can see and what they can interact with. And so I totally get the idea of like, okay, let's step away from that. And I absolutely love the idea with Heady of gradually introducing things, right? The back in slightly earlier in my career, when I was teaching juniors some C# and .NET, it changed this last year. So 2021 into 2022, when C# became simpler with the minimal APIs and global using statements and stuff like that. But previously, when I was teaching new C# developers, it was like, okay, open up your IDE, right? We're going to type in namespace using system, namespace my app, curly brackets, public static void main, curly brackets, console.writeline, hello world, curly brackets, run, right?
Yeah.
What does all of this do? Well, actually ignore everything. Those 11 lines,
Yes.
I want you to ignore everything except for line 8. And
Yeah.
even then, I need
And
to
then
teach you what.
there's so many dimensions there, right? Because it will add to the cognitive load because their brains will process. You can't say, don't look at it because it is there, right? You can tape off their monitors, but then they can scroll. So that's not very practical. So they will look at it. And also some students, and this is specifically true again for students with lower computer skills, if they come in, female students, they might have this prior impression that programming is hard, that programming is difficult, that programming is not for them. Imagine the first thing you say is, here's all these hieroglyphs, right? I like your analogy with medieval French. It's like, here's the stuff that absolutely makes no sense to you, but still you have to do it. The computer requires you to do it. That's pretty much enforcing the idea that programming is shit, and that is really hard, that there's all this magic. And you don't even understand why it doesn't matter, right? You, the expert teacher, can tell them that this isn't relevant, but why isn't this relevant? And then they forget one semicolon or one, and then suddenly it is relevant. And then you get an error message in one of the lines that you, teacher, said they could ignore. Okay, so it does matter. This is a battle you can win.
Mm-hmm. And even then, sometimes those error messages are not very clear. Thankfully, in the sort of more
Yes.
modern languages, C#, .NET, JavaScript, things like that, it is rather clear. Expect in a bracket. Oh, well, as long as you can understand those words, and I'm not saying that people can't, but, error messages are usually localized, or rather sometimes, most of the time they're English.
Yeah.
If you don't
Most of
understand
the time
that,
in English. Yeah.
yeah, right. You'll jump to that line and you'll say, well, why do I need a bracket there? Why do I need a semicolon there? JavaScript solved this issue years ago. You don't need semicolons. So why do I need them in C#? Oh, well, because the designers of the language, blah, 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 you have to go into the history of C and C++. Or you could just say, put a semicolon there, ignore it. Or you could say, right, okay, instead of doing this, let's use something that's a little more beginner friendly, like Heady, or maybe C#'s minimal APIs, global usings, that kind of thing. And we'll gradually build up. Maybe Python is better because, Python is better, or, that's just conjecture or something. And you can slowly build up that knowledge. And I love the idea of very slowly introducing things. Like you said there, you start with print and a word, and it will print the word. And then you generate a very...
And there's so many technical reasons also. So many technical reasons also why a small language is very useful. And that benefit in teaching. And so you're talking about error messages. If the error message is semicolon missing, why doesn't the computer put the semicolon there?
Absolutely.
Right? And one of the things we're working on with Heady is something called program repair. That's just fixing a program. So before we throw an error message saying a semicolon goes there, well, we don't have semicolons. We use Python, but a bracket goes there. We can just put the bracket there, see if that parses, and give with high confidence the kid the warning that this is what they should do. This is, of course, not very reasonable if you're doing professional C# development, because program repair is very expensive. And there are many things that you might try. But if you have a small language with little concepts, it also means kids will typically make relatively small programs. So things like program repair, they get reasonable. And in our lowest levels, in level 1, we just have 5 commands. So if you mistype a command, I can actually do just string distance and see if you maybe misspelled something. So there's all these things, because the language is small and the programs are small, problems that older scientists have been experimenting with at scale that are really hard to get right, like program repair. Suddenly, in this baby context, in this tiny teaching language, it gets possible to do stuff like localized error messages. We have that as well, where the error messages are in your native language. We have error messages that are like sentences, so they are not semicolon missing, but you miss a semicolon in this location. So the smallness of the language is also interesting from a technical perspective, because it allows us to do certain things that in general are possible but are so slow that you don't want your compiler to actually test if the semicolon goes there. You'll be quicker and you can see what's happening. And the program is too big, so compiling it will take too long. Whereas for a kid, this actually really makes sense.
I like that. Friendly error messages. I like that. And self-repairing code. I also like that too, because like you say, it's reinforcing that lesson. Hey, I think you missed a bracket. I put one in and it compiled anyway, but this is what I think you meant. I totally like that.
Yeah.
I love that idea. And I think perhaps we're heading in that direction very slowly anyway, with things like GitHub Copilot, and I've tried this myself. It is absolutely magic. I start typing a word and it has the rest of the line for me. Like, I mean, I know how they're doing it. I know how they're doing it. It's machine learning and Markov chains based on basically everything that's public on GitHub. But even so, it's magic to me that is the computer writing the code for me? Yes, no, So I think we're slowly heading in that direction anyway. But I love the idea of using it as a teaching tool to be able to say, hey, you've missed this character, this piece of syntax. Let me put that in for you, and then let me show you why I had to put that in. I think you missed this, that kind of thing. I love that, because then when you are learning, it reduces that pain and it is a real pain. It's not like a physical pain, but it's more like an emotional pain. Oh no, I broke it. Yeah. You were saying earlier on, teacher, I broke the computer. That's all right. Let's have a look together.
Yes.
You reduce that pain. You reduce that embarrassment as well. Because if everyone else around me gets it and I don't get it, and I don't know that I've missed a bracket, I then feel embarrassment and emotional pain at the fact that I don't get it. Which, if excuse me, you said earlier on about some students may have these preconceived notions that programming is not for them because of some background information, some information about maybe their background, maybe their identity, maybe their socioeconomic stuff. They may have these preconceived prejudices that they've put onto themselves or others have put onto them, which will be contributing towards that. And then when they feel embarrassed and upset, I've seen students literally just stop and I will sit back from the computer. I can't do this. It's not for me. It's too hard. Yeah. And it takes that.
That's such a hard thing to battle, that if students already come in with this preconception, and then they get 5 or 6 error messages, if you do Python, maybe it will be syntax error, unexpected, EOF.
Yeah.
It's like, what? And then there's like, the teacher said, just because, and this is not even my native language, right? It's not the native language of the students I teach. And even English kids, I don't think they know what syntax error means, or EOF.
Yeah.
So if this self-efficacy, what we call it, this trust that they can do it, is already quite low, and then this is the first thing you see, then you're like, my dad was right. This isn't for me. And then it's so hard as a teacher. Then, of course, we teachers, we fight against that. We're like, no, this is for you and you can do it. But clearly, it's really hard to fight something like that if it's already there. If the social circle of kids, which sadly is sometimes the case for girls, their social circle tells them it's not for them. Their classmates tell them it's not for them. And then these error messages happen. And I can fix that with being nice once.
Or perhaps, and I saw this when I was a child, perhaps the opposite happens. Because I can do it and other people can't, I'm the outcast, right?
Yeah.
Whereas if you make it possible for everyone to do it, then everyone's on a even playing field, right? There's not necessarily in that first example of print Felienne. If everyone could type print Felienne and it prints Felienne, everyone's almost equal in that. Well, everyone is equal in that respect. You don't have the rock star of the class who's being picked on because they are better than everyone else, or because they were able to. Well, I'm throwing bunny quotes around better there, or perhaps because they were able to do what teacher said and we can't, or the opposite. I can't do it, so then I feel the emotion.
And everyone can,
Exactly.
Yes. Yeah, and I think like one of the best feedbacks we got about Heady was from a teacher that used to do Python. And he said to me, when we did Python, some kids got it and they were having a great time and they were like hyping each other up, learning from each other, giving each other ideas. But that was maybe 1/3 of the group. And the rest was like, we hate this course and it is mandatory in that school. So they couldn't drop out. They had to finish the year. And he said, with Heady, everyone can do it and everyone gets to this level of excitement. And then some kids, this is also the benefit of Heady, some kids reach level 10 and they have fun there. And other kids, they stick at level 4, which is also fine because they can learn Python later. We encourage them later in their school career to do other things. But he was like, everyone is building something. Everyone is having fun. Everyone has this feeling that they can do it. I'm like, yes, this is what I want.
Excellent. Okay, so what I'll say, Felienne, is we've talked for ages, and I could legitimately, I feel like I could talk to you all day, but I know you have lots of things to do, and I'm sure the listeners have lots of things
sadly,
to do.
I have to do actual work instead of chatting to people about dream IDEs.
Well, maybe. I mean, I'm not saying the audience for the show has a huge following, but maybe we can kickstart that idea. Somebody can maybe go, oh wait, I know how to do this. Maybe I could pull in an npm package into Visual Studio Code and allow you to draw on screen and save it as a, I don't know, maybe not as an actual image, but maybe as a plot of points or something. Because then it's text
cool.
and it can be checked into source control if they need it, right?
Yes.
Excellent. Okay. So where's the best place for people to go to find out about you, maybe about Heady, and maybe about the programmer's brain, if you don't mind sharing those?
No, absolutely not. So the best place to find me is on Twitter. My handle is Felienne at Twitter. So if you know how to spell my name, then I'm easy to find on Twitter. I also have my website, felienne.com. I used to use it to blog about international trips I took before everything. So it's a bit dead now because I don't travel that much. But you can go to felienne.com/book, which is where you can find a link to the book. And it is the best link because I get a little bit of affiliate marketing through that link as well. So if you want to do me a favor and give me a few extra bucks, then go to felienne.com/book. Heady is open source and on GitHub, and also free to use. So even if you're a parent and you're not interested in helping, but you're interested, or a teacher in teaching with Heady, you can simply go to www.headycode.com. It is free. It is available in 18 different natural languages, including Hindi, Bengali, Arabic. So we also support right to left languages, Dutch, of course, French, Spanish, German, Portuguese. So whatever language you have, I would say there's a big chance that it's actually also available in the language that you and potentially the kids that you teach speak. So we love to have more users. We love to have more open source contributors. Feel free to check it out and see if it works for you.
Excellent. And what I'll do is I'll do some Googling and get all of those links, put those in the show notes. So if you're listening, don't worry about diving across your car and getting a notepad to write those down. Don't do that. Carry on driving, and you can look at the show notes later. And then I will also make a point of putting a link to the Code Reading Club as well in there, so then people can check that out too. Because that seems like a very important thing to me. To be able to actually do that in a structured way with a group of people. I feel like that's a great idea. Maybe people can start doing these things in their companies, maybe one week it's a lunch and learn, maybe another week it's a code reading club. And then maybe, like I say, someone could invent a Visual Studio Code plugin to allow you to draw on your code and annotate it with squares and shapes and boxes and stuff, because the support is in there for Visual Studio Code to do it. It's just, how do you store it?
Yeah, maybe one other link to add to the show notes is the code reading clubs. This is codereadingclubs.org. We have monthly code reading clubs that are open online and free for people to join. Every first Tuesday of the month at 7 p.m. Central European time. So this will be morning, probably, if you're in the US. Just you can join, and we always do a new code snippet just for you to figure out, hey, is this interesting? How does that work? To see if you want to do it within your company. And if people are doing it in their companies, I am quite interested to sit in. I've done that with some companies. So if people want to have me as a facilitator or just me in the audience to see, well, do they do it proper? Then also feel free to reach out, because this is a thing I've done in the past and I learn a lot from it. So I very much enjoy doing that.
Excellent. Okay, well, I guess the only thing left to say, Felienne, is thank you ever so much for being on the show, and thank you so much for sharing all of this knowledge with me today. I've got loads of points that I'm going to go away and actually roll into my own development practice. And as an actual review of the book, I do genuinely recommend that developers get your book because it has helped me. For instance, after I bought the book, I started learning Go, and I feel like, I mean, this may be confirmation bias, I'm not sure, but I feel like I've picked it up quicker than I would have done otherwise. So, I want to thank you for
Cool.
that. So, yeah, thank you very much, Felienne, and I hope you have a wonderful rest of your day.
Yeah, thanks for having me. It was really nice to chat with you.
Thank you very much. That was my interview with Felienne Hermans. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head over to .netcore.show/subscribe for ways to do that, or reach out via our contact page at .netcore.show/contact. And to come back next time for more .NET goodness. I'll see you again real soon. See you later, folks. The .NET Core podcast is a production of RJJ Software Limited.